Hello, everyone, and welcome to lesson 14. We are now coming back to trig. So today we are going to be finding exact trig values using two special right triangles. Now, before we jump into that, though, we need to recall our 6 trig ratios. Remember, we have 3 basic ones, and we have 3 reciprocal ones. So first, here I have a right triangle. I have theta down here. And then I'm going to label the sides. We have the hypotenuse. We have the opposite leg. And we have our adjacent leg. So now our 3 basic. So we have sine theta is equal to opposite over hypotenuse. Cosine theta is equal to adjacent over hypotenuse. And tangent theta is equal to opposite over adjacent. So those are our 3 basics. Then we have our 3 reciprocals. And these are the flips of our basics. So the flip of sine is, help if I spell it correctly, is cosecant theta, which is the flip. So hypotenuse over opposite. The flip of cosine is secant theta. So that is hypotenuse over adjacent. And then finally, the flip of tangent is cotangent. So adjacent over opposite. So we are back using these 6 trig ratios. So make sure you know them and you know how to find them. So our first, actually our biggest concept that we're going to be doing is special right triangles and using them to find exact values. So we have what we call the 45, 45, 90 right triangle. And it's called that because, well, the 2 angles besides the right angle are both 45. And then we have a 30, 60, 90 right triangle, which by its name has a 30 degree, a 60 degree, and then the right angle. Let's talk about the 45 first. The legs on a 45 right triangle are always the same. And we are going to keep them with a leg of 1. So both legs are 1. And then the hypotenuse is square root 2. So these are the numbers we're going to be using. 1, 1, square root 2. And then for a 30, 60, 90 right triangle, as you can see, we have a short leg, a long leg, and a hypotenuse. The short leg down here by 60 degrees is going to be 1. The long leg is going to be square root 3. And then the hypotenuse is 2. So you need to make sure you have this written down correctly for the special right triangles because we are going to be using them to find exact values. So let's do some practice with that. So here we go. So it says find exact values. And I definitely want to make mention what it means with exact values. No decimals. You are going to be keeping your answers either as a fraction or with square roots. And you have to simplify your square roots. So no taking them into decimal format. So here, they want us to find the sine of 45. So you come up here, your 45. Now, because there are 2 45s, you just pick the 45 you want to use. I like to use the bottom 45. You could use the top 45. It will get you the same answer. So here we go. Now remember, sine is opposite over hypotenuse. So my opposite from 45 degrees is 1. And then my hypotenuse is square root 2. But we're not done yet. We cannot have a square root in the bottom, so we need to simplify by multiplying top and bottom. And our final answer is root 2 over 2. So there we go. I'm going to erase that, keep it nice and neat. And we're done. Sine of 45 is square root 2 over 2. Now, cosine of 30. We're going to come over here to the 30, 60, 90 right triangle. I'm going to highlight 30. So now we're coming from 30 degrees. A reminder, cosine is adjacent over hypotenuse. So with 30 degrees, my adjacent is square root 3. And my hypotenuse is 2. And as you can see, my square root's in the top, nothing to simplify here. So we're done with cosine of 30. Now, tangent 60. I'm going to erase my marking there on 30. So now we're going off of 60 degrees for this tangent. Remember, tangent is opposite over adjacent. So tangent of 60. The opposite is square root 3, and the adjacent is 1. Now, you can either leave your answer like this, but I'm just going to rewrite it as just the square root of 3 and get rid of the 1. So there we go. So you're just using these two right triangles, and it all depends on what they tell you it is. So now let's do some flips. So here we have cosecant of 60 degrees. So cosecant is hypotenuse over opposite. Now, I'll have to scroll up. We need the 60-degree right triangle. So 60 degrees is right here. So this time, hypotenuse is 2. And then opposite is radical 3. So 60 degrees. So the hypotenuse is 2. The opposite is radical 3. And then we have a square root 3, so we have to simplify it. So this is 2 square root 3 over 3 for cosecant 60. Hypotenuse over opposite. All right, let's look at our next one. Sorry for so much scrolling up and down. Secant of 45. So we're back here. Here's our 45. Remember, secant is hypotenuse over adjacent. If we look here at our 45, hypotenuse is radical 2 over adjacent, which is 1. So radical 2 over 1, and I'm going to write it as radical 2. And then finally, cotangent 30, so adjacent over opposite. Here is cotangent 30. So adjacent is radical 3, opposite is 1. We're going to have radical 3 over 1, which is just the square root of 3. Now, be prepared. You are going to have a lot of answers that are going to be repeated, and that's okay. The reason we're going to be repeating a lot of answers is because we are only going to be using these two special right triangles. These are the only two we're going to be using. There's going to be a lot of repeats, so don't let that panic you. So now that we have the basics of our special right triangles done and you know how to use them, we're now going to look at finding larger angles. And this is where our work from lesson 13 comes into play. First off, depending on which quadrant your angles land in, that's going to tell you if your function is going to be positive or negative. So if your angle lands in quadrant 1, this one's nice. They are all positive in quadrant 1. All 6 trig ratios are positive in quadrant 1. In a quadrant 2, the only thing that is positive is going to be sine and cosecant. Cosine and secant are negative, same with tangent and cotangent. So if your angle lands in quadrant 2 and they ask you for a cosine, your answer is going to be negative. In quadrant 3, sine and cosecant are negative. Cosine and secant are also negative, and the only positive, tangent and cotangent. And then finally, quadrant 4, sine and cosecant are negative. Cosine and secant are positive, and tangent and cotangent are negative. We're going to be using this chart to identify positives and negatives. So now let's get into finding exact values between negative and positive 360. There are 4 steps that we're going to take. And as long as you follow these 4 steps, it'll go easy peasy. First, sketch the angle to find the reference angle, meaning your angle is going to be one of 3 reference angles. You're either going to have a 45-degree angle, a 30-degree angle, or a 60-degree angle. And the reason is, those are the triangles we used. There's only 2 right triangles we'll be using this whole time, and it's going to have one of these 3 angles. After you determine what your angle, your reference angle is, then you're going to draw the corresponding right triangle. Then we're going to evaluate the function, like we did up top, and then determine if it's positive or negative. So let me show you how these steps work. So this first one is sine of negative 120. So the first thing we're going to do, we're going to sketch an angle. So negative 120 lands us right over here in quadrant 3. So now we have to find this reference angle. So what we're going to do is negative 120 plus 360, because we have to find our coterminal first. And this is going to be 240. Then find the reference angle. Since we're in quadrant 3, we're going to take our coterminal, 240, subtract 180, and that gives us 60 degrees. So this 60 tells us the right triangle we're going to use. So we are going to use our 30, 60, 90 right triangle. Ooh, I'm just trying. Nope, that's not going to work. I thought I could keep drawing a right triangle. Turns out, nope, it didn't look quite right. So now we're going to get my wonky drawing one. Sorry, I didn't like it. All right, let me try this again. Oh, that does not look even better. That's all right. So we have 60 degrees down here. Short side is 1. Long leg is √3. Hypotenuse is 2. So we have sine, and again, sine is opposite over hypotenuse. So sine of negative 120 is equal to, so we go from our 60, opposite is √3. Hypotenuse is 2. And then finally, the last thing we have to look at, is it positive or negative? We landed in quadrant 3. Look up top. In quadrant 3, Sine is negative. So all you have to do now, attach a negative in front. And there's our answer. All right, next one, cosine 240. Cosine is adjacent over hypotenuse. We draw, this is positive 240. So it's gonna land us right down here. We're in quadrant 3 again. And because it's positive 240, we do not have to find a coterminal. We just jump right in, find our reference, which is still 60 degrees. So 60 is our reference here. I'm going to draw another right triangle with 60 degrees. Long leg is square root 3. Short leg is 1. Hypotenuse is 2. So cosine of 240 is equal to, so my adjacent of 60 is 1. My hypotenuse is 2. And again, I'm going to scroll up. Quadrant 3, cosine is negative. So we have to attach a negative onto our 1/2. So there we go. Cosine of 240 is negative 1/2. Next, tangent of 35. Tangent is opposite over adjacent. So draw and sketch. So 315 is going to land us over here in quadrant 4. So for our reference angle, we're going to do 360 minus 315, and that is 45 degrees. So our reference angle is 45, meaning we're going to use our 45 right triangle. Here we go. 45. Remember, both our legs are 1. Hypotenuse is square root 2. So tangent of 315 is equal to opposite over adjacent. So we have opposite is 1. Adjacent is 1. So we have 1. But again, we still have to find if it's positive or negative. I'm going to scroll up. Quadrant 4, tangent, negative. So we have to attach a negative onto the 1. So tangent of 315, negative 1. All right, we have 3 more to go, and now we're doing reciprocals. Cosecant of negative 330. So remember, cosecant is hypotenuse over opposite. We have a negative 330. So negative 330 is going to put us in quadrant 1. But we have to find our reference or our coterminal. So negative 330 plus 360. And this is going to be equal to 30 degrees. And because we are in quadrant 1, our coterminal and reference angle is the same. So we have 30 degrees. We're going to draw our 30, 60 right triangle. 30 degrees up here. Short side is 1. Long side is square root 3. Hypotenuse is 2. So cosecant of negative 330 is equal to, all right, hypotenuse on top because it's hypotenuse over opposite. So we have 2 over opposite of 30 is 1. So this is going to be 2. And then remember, anything that lands in quadrant 1 is positive. So we leave it as positive 2. Next, secant of 135. Secant is going to be hypotenuse over adjacent. So draw our angle. 135 lands us in quadrant 2. And since it's positive, and in quadrant 2, we're going to do 180 minus 135. And this is going to give us a 45. So that is our reference angle. So we are using our 45 right triangle. Legs are both 1. Hypotenuse is square root 2. So secant of 135 is equal to. So my hypotenuse is square root 2. My adjacent is 1. So we have the square root of 2. But we're in quadrant 2. And cosine and secant are negative in quadrant 2. So we need to attach a negative onto the square root of 2. And finally, last one, cotangent of negative 30. Cotangent is adjacent over opposite. So negative 30 is right here. We're in quadrant 4. Negative 30 plus 360 is equal to 330. So 360 minus 330 is, 30 degrees. So that is our reference angle. Draw my 30, 60 right triangle. Remember 30 is up top here. Short side 1, long side, square root 3, hypotenuse 2. So we have cotangent of negative 30 degrees is equal to, the adjacent is square root 3. My opposite is 1. So this is square root 3. But again, negative or positive. If we look back, quadrant 4, tangent and cotangent are negative. So we attach a negative. And there you have it, finding exact values using our two special right triangles.